I received some questions from students about the empirical rule, which is called the 68, 95, 99.7% rule. And let me explain this to you quickly. If you have a data set and then when you graph it, when you do a histogram, it has a bell-shaped curve, a histogram that looks like a bell-shaped, then the empirical rule would apply to this data set. What does the empirical rule say? It says that 68% of the data, as you can see me, I'm shading here 34 and 34, fall within one standard deviation of the mean. What does that mean? For example, let's say they'll give you the mean to be 100. And let's say the standard deviation is given to be, for example, 8. Okay, so that would be the mean right here, 100. Okay, here it says mean plus one standard deviation, so that would be 108. And here it says mean 1 minus 1 standard deviation, that would be 92. So it means, let's say we have values in the data set. It means that 68% of the values in the data sets are between 92 and 108. So usually most data sets, guys, when you graph them, they will have the shape of a bell-shaped curve, and usually 68% of the data values fall within one standard deviation of the mean. What kind of questions you will have pertaining to empirical rule? For example, he will give you the mean 100, he will give you the standard deviation to be 8, and he'll ask you what percent of the data fall between 92 and 108. Well, you know, if you take 100 and you add one standard deviation, you get 108. Subtract one standard deviation, you get 92. So then the answer is 68%. Now, let me add another standard deviation. So that will be 108 plus 8, 116. And that will be 92 minus 8, which is 84. And let me shade this. Now you see there's more blue shading. 95% of the data falls within 2 standard deviation of the mean. What does that mean? For example, if he asks you what percent of the data would fall between 84 and 116, you look at 116, it's a result of adding twice the standard deviation. And you look at 84, it's a result of subtracting standard deviation from the mean twice. This is 95%, and that's why we call it the 68, 95, 99.7% rule. Now let's subtract one more standard deviation. So 84 minus 8 will give me what? 76. And 116 plus 8 will be 124. If he asks you what percent of the values that you have in the data sets are between 76 and 124, you will say 99.7%, because the 124 is a result of adding 8 plus 8 plus 8 to 100, and the 76 is a result of subtracting 8 from 100. And this is what we mean by the empirical rule, which is called 68, 95, 99.7% rule. And this rule will apply only if your data set has the shape of a bell-shaped curve, or they call it normal curve. And the questions that you should expect, for example, on the test, I will give you the mean, I will give you the standard deviation, ask you what percent of the values fall between 76 and 124. You go to 100, you add 8 3 times, you get 124. You subtract 8 3 times, you get 76, then you know the answer should be 99.7%. I could ask you, for example, what percent of the data fall between 100 and 108. Well, you know, when you add one standard deviation only and you don't subtract standard deviation, you don't get the entire 68, you get half of them, which is 34%. This curve that you see right here is very helpful, and it breaks out the curve, you know, into smaller pieces. Now we probably ask me, well, we should have 100% of the data values. What happens to the remaining percentage, which is very small, 0.3%? These are very much the outliers, the extreme values that don't belong there. So they will be way, way toward the right or way, way toward the left. I thought to explain this quickly to you guys. So if you have any questions about the empirical rule, I hope that I was able to clarify it.